Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss the sequential container. For example, vector. So what is a sequential container? It is the container used to store the element in the sequential order. The implementation data structure which can be accessed in the sequential manner. For example, vector, list, DQ, arrays. We'll discuss one by one. First, we'll start with the vector. So what is the vector? It is similar to dynamic array with ability to automatically resize itself when the element are inserted or deleted. The element in a vector are stored in the continuous memory location, which allow the efficient access and travels using the iterator or indexing. The vector typically insert the element at the end using the pushback functions. What is the time complexity for inserting element and deletion element? While inserting element at the end and deletion element at the end, the time is constant. But the insertion, deletion, the element at the beginning or middle, that cases the time is linear because the element need to be shifted. And next one is functions that is associated with the vectors. So here there are four categories there: iterators, capacity, element access, and modifiers. We'll discuss one by one with an example. First, we'll start with the iterators. So it has some of the inbuilt functions. For example, begin. So it will return on the iterator the pointing to the first element. And next one is a n. It will return the iterator the pointing to the just after the last element. And next one is a or begin. It will return the reverse iterator. It will point to the last element. And next one is a or n. It will return the reverse iterator which will point to before the first element. And next one is a C begin. It will return the constant iterator. It will point to the first element. And next one is a Cn. It will return the constant iterator that will point to the position just after the last element of the container. And next one is C or begin. It will return the constant reverse iterator which will point to the last element of the vectors. Then C or n. It will return the constant reverse iterator that point to the position just before the first element of the container. We will see one example using the functions. For example, here we are creating the object from the vector. This belongs to the integer. So now we are going to push the value into the vector using pushback functions. For example, here we are using the for loop. The for loop, it will rotate 5 times. So every time it will get the values. The value we are going to push back into the vectors. For example, first the 1, it is inserted in the loss. Again, the next value insert in the loss, and next insert at loss, at insert loss, and last again it is insert in the loss. Like that, we are going to insert the value in the backside of the vector. So if you want to see the result or the content of the vector, so here we are using the for loop. So here the for loop, the g1 dot begin mean the pointer is point to the first. Then next one is, then we are going to verify till the end of the vector is empty or not. So if content is there, then it will print. So like that, the for loop is rotated. Every rotation, it will get the inputs from the vector, then it will show that. And next one is the output of the C begin and Cn. So here, similarly here we are using the for loop. Now we are using C begin and we are going to verify till end of the vector. Then we are going to increment. We are going to get the value from the vector. Then we are going to display. For example, 1, 2, 3, 4, 5, because already only the 5 value is that is insert in the vector, right? It will show the same result. And next one is we are going to show the output of the or begin and or end functions. So now the for loop start with or begin. We are going to verify till r1.n. So or begin means what? So it will start from the end. Then automatically it will from the reverse order, right? Because or begin. So start from the end, then till it will the control is moved to the beginning. First the 5 it will print, then 4 it will print, then 3, then 2 and 1. And next the output of the CR begin and the CR end, it will show the same result because we are going to start from the end of the vectors till we are going to move towards the beginning of the vectors. And next one is the capacity. The capacity has some of the inbuilt functions. For example, size. It will return the number of element in the vector. And next one is the max size. It will return the maximum number of element that the vector can hold. And next one is the capacity. It will return the size of the storage space currently allocated to the vector. And next one is the resize. If you want to resize the capacity, then we can change it. And next one is empty. Here we are going to verify whether the container is empty or not. And next one is string to fit. Then we are going to reduce the capacity of the container to fit its size and destroy all the element beyond the capacity. And reserve. So here recovers to the vector to allocate the memory at least n elements. I will see some example program using the functions. So for example, here the object is created from the vector. So now we are going to reserve the memory space. So now here 8. So now 8 memory space is allocated. See, 1, 2, 3, 4, 5, 6, 7, 8 memory space is allocated. Then we are going to push the value into the memory location of that is the vector memory location. So now the loop is 5 times it will rotate. Every time it will get the I value. Then we are going to push the value in the vector. For example, 1, 2, 3, 4 and 5. Now we are going to call some inbuilt function. Then we will see the result. For example, g1.size. So g1.size means what? How many element within the vectors? 1, 2, 3, 4, 5 element, right? The result is 5. And next one, g1.capacity. Capacity means that is the reserved space. How much memory space is reserved here? So here 8 memory space is reserved. And next one is g1.max size. So then it will tell the maximum size. And next one is if you want to resize, then we can do it. So now we are going to reduce the memory space. For example, resize is 4. So automatically the 1, 2, 3 and 4 up to the memory space is removed or destroyed. So now after destroying up to this, now we can see the g1.size means what? Only the 4 element, because up to this the element is removed. And next one is g1.capacity, but already reserved capacity is for 8, right? That it will display. See, but temporarily we are going to resizing here, but actually the allocated memory space is 8, then it will display. Now we are going to verify whether the vector is empty or not, because already some other content already exists in the vector, right? So it will show that the vector is not empty. Now we are going to reduce the memory space. We are going to fit according to the inputs. So here the input is only 1, 2, 3, 4, right? Because already resizing is 4, right? Here only the 4 element. According to 4 element, so we are going to reduce the memory space. We are going to fit according to the input. So now the remaining all the element and space will be destroyed completely. So up to this destroyed. So what is the value right now? So now 1, 2, 3, 4. What is the capacity? Now 4. And next one is the element access. The element access, it has some of the inbuilt functions. For example, reference operator. So it will return the reference to the element at the position G in the vector. But here there is no bound checking. So next one is the at G. It will show the same result, but the difference, it will perform the bound checking. And next one is the front. It will return the reference to the first element the vector. And next function back, it will return the reference to the last element in the vector. And next one is the data. It will return the pointer to underline the array. We'll see the example using the functions. For example, the object is created from the vector. Now we are going to push the value 10 times. So first get the I value. The I value is multiplied with the 10. We are going to push back in the vector. So the for loop is 10 times rotated. Every time we are using the formula, then we are going to multiply. Then we are going to insert the value in the vector. So we are going to insert like that. And next, if you want to see the content of the vector, so we can use the for loop. So here the for loop, we are going to start with the beginning. We are going to verify till the end of the vector. Then we are every time it will get the value from the vectors, then it will show that. And next we are going to use the functions. For example, g1.2. It means what is the second position of the value. See, what is the second position of the value? 30. That will be print. And at 4, it means what is the fourth location of the values. The fourth location of value is 50. That will be print here. Already told you, right? Both are the same result. The operator and then at both it will show the same result. And next one is g1.front. What is the front value? 10. Then g1.back. What is the last value in the vector? 100. That will be print. Then g1.data, it is stored in the point variable. So now we are going to print the point position variable. So now automatically it will start with the first value. The value is 10. And next one is, we will take a new input. The vector, it has 1, 2. The second vector, it has 3, 4. Now we are applying the swap operation. v1 dot swap v2. So what will happen? Ultimately, the content of v2, it is moved to v1. The content of v1, it will move to the v2. So now we will verify the result of v1. So now 3, 4 and 1, 2. Thank you. Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss list concept in the sequential container. First, we will discuss some of the drawbacks in the vector concept. The vector is a sequential container that allows the continuous memory allocation. Insertion, deletion in the middle of the vector is very costly because it takes a lot of time in shifting all the elements. The linked list overcomes this problem and it is implemented using list container. The list are sequential container that allow non-continuous memory allocation. It supports the bidirectional and it will provide the efficient way for insertion and deletion operation. As compared to vector, the list has slow travels, but once the position has been found, the insertion and deletion are very quick. The list support the double linked list also. The functions associated with list. So there are different type of inbuilt functions there. We'll discuss one by one. First one is the front. So it will return the value of the first element in the list. And next one is the back. It will return the value of the last element in the list. And then push front. So add the new element G at the beginning of the list. Then push back. So add the new element G at the end of the list. And pop front. It will remove the first element of the list. Then pop back, it will remove the last element of the list here. And next, some additional functions we'll discuss. Begin, it will return the iterator which will point to the first element of the list. Next one is the end, it will return the iterator which will point to the theoretical last element which follow the last elements here. And next one is the or begin, it will return the reverse iterator which point to the last element of the list. Then reverse end, it will return the reverse iterator which point to the position before the beginning of the list. And next one is constant begin, it will return the constant random access iterator which point to the beginning of the list. And next one is constant end, it will return the constant random access iterator which point to the end of the list. And next one is constant reverse begin, it will return the constant reverse iterator which point to the last element of the list. And next one is constant reverse end, it will return the constant reverse iterator which point to the theoretical element preceding the first element of the list. And next one is the empty, it will return whether the list is empty or not. If it is empty, it will return 1, otherwise 0. And next one is the insert functions, it will insert the element in the list before the element at the feasible position. And next one is the erase, it will erase the single element or range of the element from the list. And next one is the assign, assign the new element to the list by replacing the current element and resize the list. And next one is remove, remove all the element from the list which are equal to the given element. And next one is the reverse, it will reverse the list here. And next one is size, it will return the number of element in the list. And next one is list resize, it is used to resize the list container. And next one is the sort, it will sort the list in the increasing order. And next function max size, it will return the maximum number of element a list container can hold. And next one is unique, it will remove all the duplicates. And M-place front, it will insert the new element into the list container. The new element is added to the beginning of the list. And next M-place back, the insert a new element into the list container. The new element is added at the end of the list. And next one is a clear, it will remove all the element of the list container, thus making it size 0. And next one is the operator, so the assigning the new content to the container by replacing the existing contents. And next one is swap, it will swap the content of one list with another list. And splice, it will transfer the element from one list to another. And next one is a merge, merge the two starter list into one. And next one is mcase, the external list by inserting new element at a given position. Like that, here we are going to apply this all the function the program, then we are going to see the result. So finally it will print like that. Thank you. Hello everyone, welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss DQ concept which belongs to the sequential container. In sequential container, the DQ support push and pop operation from both ends. In regular queue, actually the element is added in the rear end and then the element is removed in the front end. But in the DQ concept, we can insert and remove element from both front and rear. It means what? So in the front side, right, where we can insert the element, where we can delete the element. Similarly, the rear side, where we can insert the element, we can delete the element. It means what? We can insert or delete operation is done both sides. So what is the characteristic of DQ? dynamic size container. It support random access using index. And next one is the fast insertion and deletion at both ends. The elements are not stored in the continuous memory locations. It is more flexible than vector for the front-end operation. And next, methods of queue. First one is the insert. So insert the element and return the iterator that point to the first of the newly inserted element. And next one is or begin. That is the reverse, right? Reverse begin. It will return the reverse iterator which point to the last element of the DQ. And next one is reverse end. It will return the reverse iterator which point to the position before the beginning of the DQ. And next one is C begin. That is the constant begin. It will return the constant iterator which will point to the first element of the container. That is, the iterator cannot use it to modify, only traverse the DQ. And the max size. It will return the maximum number of elements that the DQ container can hold. And next one is the assign. Assign the value to the same or different DQ container. And next one is the resize. The function which change the size of the DQ. And next two functions. Push front. So now push the element into the queue from the front side. Next one is a push back. Push the element into the DQ from the back side. Pop front. Pop means what? Remove, right? Remove element from the front. Pop back means remove the element from the back side. And front, it will reference to the first element in the DQ container. Back, it is the reference, the last element of the DQ. Clear. Remove all the element of the DQ container, thus making its size is 0. Erase. It will remove the element from the container from specified position or some of the ranges. And next one is the empty. Check if the DQ container is empty or not. And next one is the size. It will return the size of the DQ container or the number of elements in the DQ container. Okay. Now here we are going to apply this all the function. Now we are going to build one program. So we will see the responsible and the result of the functions. So here void show is one of the functions. So what is the role of this function? Simply it will display the content of the DQ. So start from the beginning, then it will reach the end of the DQ, then every iteration, then it will get the value from the DQ, then it will show them. So it will, what is the main function of the show here? It will simply display the content of the DQ. So here the main program, here the object is created from the DQ. So now we are going to push the value in the DQ. So two way we can push, right? Front side also you can insert the value and back side also you can insert the value. So now push back 10. So now the 10 is inserted. And next one is push front 20. So the 20 is inserted here, front right. Then the 30 is inserted in the back side. So the 30 is inserted in the back side. And then the 15 is inserted in the front side. So now 15 is inserted in the front side. So again, so here after that, if you want to see the content of the DQ, then we will call the functions. Automatically it will show like that 15, 20, 10 and 30. Again, if you are calling the size, it will tell the number of element in the DQ. How many element? 1, 2, 3, 4. Then D dot max size, it will tell the maximum size here. And at 2 means what? What is the second position element? 0, 1, 2. What is the value here? 10, that will print. Then what is the front of the DQ? 15. What is the back side of the DQ? That is 30, that will print. Then pop front. So pop front means what? That is the front value, right? So now it is deleted. So what is the remaining value? 20, 10, 30. And pop back means what? It will remove the backside value. So here here the backside value removed, right? So what is the remaining value? Only 20 and 10. So this is the way. So we are going to build the program using the inbuilt functions. Thank you. Hello everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss array concept in the sequential container. The array classes knows its own size. So, no need to pass the array size of the array as a separate parameter here. The array classes are generally more efficient, lightweight, and reliable. So, what are the features of array here? It is fixed size. The element stored in the continuous memory location. It supports random access. It is faster than dynamic container. And next one is the operation on array. First one is add. It will access the element of the array. And next one is a get. It will access the element of the array. It means what? Both are used to access the element of the array. And next one is the operator. It is similar to C-style array. This method is also used to access the array element. We will see an example using the functions. For example, the array, from the array, then we are creating the array name which will hold the values. For example, 1, 2, 3, 4, 5. And the next one is here is a for loop. It will rotate. So here every rotation it will get the value, then it will display. But here we are using the add functions. Okay, add function means what? It will identify the position, then it will get the corresponding value, then it will display in the each rotation. So now automatically for example 0. What is the 0th location value? 1. Then first location value 2. Next location value 3. Next location value 4. Next location 5. Next location 6. So that is the for loop is rotated. Then each rotation it will find the location of the value, then it will display. And next one is the another way we are going to get the value of the array. For example, get method. Get 0th position means what? 1. The first position 2. The second position 3. Third position 4. And fourth position 5. And fifth position is 6. That will be printed here. Again we are using the another methods. For example, that is the AR, and we are going to mention the position. So in the position, 0th position means what? AR of 0th position 1, then 2, 3, 4, 5, 6. It means the same value is printing using different method. One is the add method and a get method and a normal operator method here. And next one is a front. It will return the first element of the array. Back means it will return the last element of the array. We will see one example. For example, the array, it has some values 1, 2, 3, 4, 5, 6. Okay. So now with the help of the array, then we are calling the function name. So AR.front. What is the front value here? 1. It will display. AR back. What is the last value here? 6. That will be displayed here. And next one is the side functions. It will return the number of element in the array. And max size, it will return the maximum number of element array can hold. For example, it is the array. So then array name, it has some other values. For example, 1, 2, 3, 4, 5, 6. So now with the help of the array name, then we are invoking the function, right? So now this object, right? So now the object is created from the array. So with the help of object, again we are invoking the function name size. So then it will tell that is number of element in the array 1, 2, 3, 4, 5, 6, right? And again it will tell the maximum size of the array. So result is 6. And next one is a swap. So it will swap all the element of one array with another. For example, we will take two array. So first one is object is created from the array class. It will hold some value. For example, 1, 2, 3, 4, 5, 6. And then we are creating one more object from the same class. That is array. Then it will hold some value 7, 8, 9, 10, 11, 12. So now we are going to display the element of the first array. So here we are using the for loop. At the same time, we are using that is operator functions. For example, a or I. So then, so what is zeroth location value? 1, and every time it will rotate and increase in the I value. Then it will identify the corresponding positions value. Then it will display. And similarly, the second array. So the second array here, right? So now the for loop is rotated. So each rotation, it will get the value of the array, then it will display. So the first one is 1, 2, 3, 4, 5, 6. And then here, the result is 7, 8, 9, 10, 11, 12. So now the first array object AR swap with the second object from the array, right? Already created AR1. What will happen? The content of AR1 is moved to AR. Again, the AR content is moved to AR1. So after swapping, then we are going to verify the first array content. So the first array content become 7, 8, 10, 11, 12. The second array contain, it will contain 1, 2, 3, 4, 5 because the array content is swapped here. And next one is the empty and fill functions. So the empty, it will return true when the array size is 0, else return false. And next one is a fill. It will fill the entire array with the particular value. We will see one example. So see here the array integer, the size is 6, the object is created. And next one is array, the integer, the size is 0, and then here one more object is created. So now the AR1. So now here the AR1 dot empty. We are going to verify is it empty or not. Yes, because empty. Now here AR, that is this one, right? Now AR filled with 0. So here how many capacity is 6, right? So now all the 6th place replaced with 0 here. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss stack concept in STL. What is the stack concept in STL? Stack is a container adapter that follows LIFO, that is LIFO, LIFO concept. It means last in, first out principle. So what is the meaning of last out and first out principle? The most recently inserted element is removed first, and the first inserted element will be removed last. For example, the insertion of element 10, 30, 20, 5, 1, we are going to insert in the STL stack. So how it will follow the principle? So here the STL stack, it will allocate the memory space dynamically whenever we are inserting a new data. Similarly, it will deallocate the memory whenever we are deleting data in the stack concept. So for example, we are going to insert the first element. So that cases, it will allocate the memory space automatically, that is dynamically. Then pointer top, it will point to the top of the stack. So is the first allocated memory, the pointer is point to here, where we are going to insert the first element. So that is the first element here, 10. 10 we are going to insert here. And next we are going to insert the next value 30. So now automatically it will allocate the new memory space, the pointer it will be increment, then it will point the top of the stack where we are going to insert the new element 30. Similarly 20. So now the memory space will be allocated, the pointer will be incremented, the pointer will point to the top of the stack where we are going to insert the new element 20. And similarly, so next value 5. So again the memory will be allocated, the pointer will be incremented, it will point to the top of the stack where we are going to insert the new element 5. And next, one more value, automatically it will allocate the memory space, the pointer will be incremented, it will point to the top of the stack where we are going to insert the new element 1. Likewise, we are going to insert all the new element the top of the stack. Suppose if you want to delete the elements, for example, we are going to delete element 1 and 5 in the STL stack. So that cases already we informed, right? The most recently inserted element is removed first. Which one is the most recently inserted element? 1. So now the pointer is point to the top of the stack. So the most recently inserted element is 1, that will be deleted. So automatically the point will be decremented. It will point to the next value. What is the next value? 5. Similarly, we are going to delete value 5. So now automatically deallocate the memory space. So now pointer will be decremented. Then it will point to the next new element, that is the 20. So likewise, we can delete the element from top of the stack. And next one is function associated with the stack. For example, there are different type of inbuilt function it will support. First one is a empty. It will verify whether the stack is empty or not. It will return. And next function is size. It will return the size of the stack. And next one is a top, is the one of the inbuilt function. So it will return the reference to the topmost element of the stack. And next one is a push function with the parameter. So where we are going to add the new element in the top of the stack. And next one is pop. It will delete the topmost element of the stack. So we will apply this all the inbuilt function. We will develop one example program. See here one example program. First we are defining one function, that is a void show stack. It will show that is the content of the stack. So here stack, from the stack we are creating the object. So here we are using the while because the stack having more number of element, right? So we are using the while concept. Then we are going to verify whether the stack is empty or not. If not empty, then with the help of the object, then it will point to the top. It will display the first element. Then s.pop mean the pointer will be decremented. Again, it will verify whether the stack is empty or not. Again, if not empty, it will show the content. So likewise, it will execute and then it will show all the content of the element. And suppose the stack is empty, then it will terminate the loop. So here the main program. So here from the main program, we are creating the object from the stack. With the help of the object, then we are calling the push function. So already we discussed the push function, right? To insert the element in the stack. That is the top of the stack. For example, s.push 10 mean first the 10 will be inserted. Next to push 10, that mean the 30 will be inserted in the top. Then s.push 20, so it will be inserted in the top 20. Then s.push 5, it will be inserted in the top of the stack 5. Then push 1, it will be inserted in the top of the stack. So now the pointer is pointing to the top of the stack. Suppose if we want to show the content of the stack, so then we will call the function. That is already we defined, right? We will call the function with the parameter yes. So automatically it will invoke the function. Then it will show the content of the stack. See here, what is the content of the stack? So now 1, 5, 20, 30, 10 it will show. And here, what is the size of the stack? So number of content inside the stack. 1, 2, 3, 4, 5. So here value is 5. Which one is the top of the stack here? See 1. And next one is s.pop. So what is the role of the pop here? It will delete the element. That is, it will delete the top of the element. So which one is the top of the element here? So 1 will be deleted. The top it will decrement, then it will point to the next element 5. So now again, if you are calling the show function, it will show the content of the stack. What is the current content of the stack here? Starting from here, right? Already 1 is deleted. So 5, 20, 30, 110. So likewise, it will display. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss map concept in associative containers. First, start with the associative container. The associative container or STL container, it will support direct access to the element using key. The element are automatically organized, that is, usually in the sorted order based on their key. The stored data in a structure called tree, which facilitate fast searching, deletion, and insertion. There are 4 types: set, multiset, map, and multimap. We'll discuss one by one. What is meant by set? Store unique element in the sorted order. Multiset means store the element with the duplicate. And next one is map. Store key value pair with the unique key. And multimap means store key value pair with the duplicate key is allowed. So we will start first map concept. It will store the data as key value pair. The key must be unique. That is, the duplicate key is not allowed. And next one is the element are stored in the sorted order by the key. Next, we will discuss the function associated with map concept. First, we will start with begin. It will return the iterator to the first element. And next one is the end. It will return the iterator to the element after the last. And next one is or begin. Return the reverse iterator to the last element. And next one is or end. Return the reverse iterator to the position before the first. And next one is the size. It will return the number of elements. And next one is empty. Check whether the map is empty or not. And next one is a find. Searches for the key and return the iterator. And next one is a add. Access the value associated with the key. And insert. It will insert the key value pair into the map. And next one is erase. It will remove the element by key or iterator. Swap. It will swap the content of 2 maps. And next one is a clear. It will remove all the element from the map. And next one is emplace. It will construct and insert the element efficiently. And next one is count. It will return 1 if the key exists, otherwise 0. And lower bound. It will return the iterator to the first element, not less than the given key. And next one is the upper bound. It will return the iterator to the first element greater than the given key. And next one is equal range. It will return both lower and upper bound for the key. So here we are going to apply these functions. We will build one example program. For example, so here we are creating object from the map. With the help of the object, then we are going to call inbuilt function. First we will call insert functions, which will insert the key value pair. For example, 1 is a key, apple is the values. So now first we are going to insert first content, then followed by we are going to insert 2, arrays, and third one is we are going to insert 3, banana. So 1, 2, 3 is the key. Apple, orange, banana is the value. Now we are inserting the values as key value. Next one is we are creating the iterator reference from the iterator which is belongs to the map. Then we are going to display at the corresponding value of the position. For example, at to 1, what is the value of the 1 here? Apple, it will display. At to 2, what is the value of the 2 here? Orange, it will display. Then this is the M3. So M means here, that is the here already we create object, right? The what is the position? The third position value, banana. So what is the result here? Apple, orange, and a banana. Now we are going to change the value associated with the key. So now the mango is the new value we are going to assign at to position 1. That is the key 1. So now key 1 value is changed, mango. Then key 2 value is changed as the grapes. So now the 2 value is changed. Now we are going to call the for loop. We are going to display the contents. For example, m.begin, we are going to verify till n. Then we are going to display the every iteration. For example, iteration first iterator first, it will show the key. Then iterator second it will show the value. So what is the key and the value now? Right now after changing. So mango, that is 1 comma mango, and then 2 grapes, and then 3 banana. It will display, right? And next we are going to assign the value m into n. So now we are going to copy the content from m.begin to m.n. Then we are going to copy into n. So again we are calling the for loop. It will display the same value, right? Simply we are copy the content of m into n. So n dot first, that is for example we are going to verify n.begin till we are going to verify n.n. Then we are going to display the key, then values. So now it will display mango, grapes, and then banana. Because already it is changed right here. Mango, grapes, and then banana. Then we are going to erase the value at a specific position. For example, n.erase 1 means the first content is erased. Right? Then we are calling the for loop. So what is the remaining value? So already mango is erased. Now what is the remaining value? So now here 2 dot grapes and next one is 3 banana. Right? Because first key value erased, right? The remaining 2 grapes and then 3 banana, it will display. So see, like that, it will display. So the output of the map. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss multi-map concept in associative container. A multi-map is an associative container that store element as key value pair, where the multiple element can have the same key. The elements are automatically stored in a sorted order of key. It is very useful in the competitive programming. Next, functions associated with multi-map. We'll discuss one by one. First one is the begin. It will return the iterator to the first element. End. Return the iterator to the element after the last. Or begin. Return the reverse iterator to the last element. Or end. Return the reverse iterator to the position before the first. The next size, it will return the number of elements. And next, empty. Check whether the multi-map is empty. And finally, here, find. Return the iterator to the first occurrence of the key. And next functions. Insert, it will insert the key value pair. The next function, erase, it will remove the element by key or iterator. The next function, swap, swap the content of two multi-map. Next, clear, it will remove all the element from the multi-map. The next function, emplace, construct and insert the element efficiently. And next function, count, it will return the number of elements with the given key. The next function, lower bound, it will return the iterator to the first element with the key. And next one is upper bound. It will return the iterator to the element after the last occurrence of the key. Then last one is equal range. It will return a pair of iterator represent the range of element with on key. We will discuss one example. So first we creating the object from the multimap. So with the help of the object, then we are going to call the inbuilt function. For example, insert. It will insert the key value pair. For example, 1 is a key, 40 is the value. So now we are going to insert the key value pair. For example, we are inserting 1, 40, 2, 30, 3, 60, and 3, 6, 50, and 6, 10. See here, that is same key but different value. It means more the multiple value, it will refer the same key. That already I informed you, right? It will allow the duplicates key. Next, we are creating the iterator reference from the iterator. So now we are going to display the key value pair using the for loop. For example, this reference itr dot first it will point to the key, itr second it will point to the value. So now it will rotate till end, then it will display the element like that. 140, 2, 30, 3, 60, 650, then 610. Next, we are adding the new elements randomly. For example, key value 4 and value is 50. Next key is 5 and value is 10. We are inserting randomly. But what is the beauty of this concept? It will order the element automatically. So first it will order the element automatically. Okay. Then it will insert the particular places. For example, see 4, 50, then 5, 10. So see first the order, then it will display here. 1, 2, 3, right? So now we are under 2 with the value. So it will show the remaining value using the for loop. Next, remove all the element with the key. So now we are going to physically remove only the particular position. That is, for example, key value 4 with their key followed by value. For example, second object name dot erase and 4 means what? Automatically the key and corresponding value will be removed. So what is the remaining here? So 3, 5, 6, 6 because the 4 is removed. So now we will see using the for loop. And next one is we are going to find the lower bound and upper bound. So here the lower bound of 5, the key, then lower bound of 5, its value. So then it will show the 5 and the element is 10. Similarly, the upper bound of 5 first, the upper bound of 5 second, it will show its upper bound value, that is 6, and element corresponding value is 50. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss the iterator. What is an iterator? It is on the object that behave like pointer to traverse and access the element of the container. They allow the container traversal without exposing the internal structure. What are the different type of iterator? Input iterator, output iterator, forward iterator, bidirectional iterator, and random access iterator. We'll discuss one by one. First one is the input iterator. It reads the element from a container sequentially, that is one pass. Move only the forward. Example, ISTM iterator. And next one is the output iterator. Write element to a container. This also sequentially, one pass. Move only the forward. Example, OODP iterator. Next one is a forward iterator. Read and write. It will allow the multiple passes through the container. It will move only the forward multiple times. It is used by forward list, unordered set, unordered map. And next one is bidirectional iterator. It will move forward and backward in a container. The operation is increment and decrement. It is used by list, set, map, multiset, and multimap. And next one is random access iterator. It will move freely to any position using the arithmetic operation. It is used by vector, DQ, and array. Next one is what are the functions associated with the iterator? We will discuss one by one. First function begin. It will return the iterator pointing to the first element. And next one is the end. It will return the pointer. It is pointing to after the last element. And next one is or begin. It will return the pointer, that is the iterator. It will pointing to the last element. And next one is the or n. It will return the reverse iterator. It will point to before the first element. And next C begin. It will return the constant iterator. It will point to the first element. Next one is Cn. It will return the constant iterator that point to the position just after the last element of the container. And next C or begin. It will return the constant reverse iterator. It will pointing to the last element, the vector. And next one is C or end. That is, it will return the constant reverse iterator that point to the position just before the first element of the container. We'll see one example. For example, so here the vector, from the vector we are creating the variable, it will vector variable, it will collection of the element. For example, 10, 20, 30, 40 and 50. So now we are using the for loop, we are going to print the content of the vector. For example, every rotation it will take a single value from the vector, then it will display. So now it will go till end of the vector, then it will display. So what is the result here? So every rotation it will take one value, right? So 10, 20, 30, 40 and 50. And next one is we are using C begin, that is constant begin. Then we are going to verify till the constant n. Then we are going to print the value. It is only for the read only. So now it will print the same, right? 10, 20, 30, 40 and 50. Next we are used, that is the reverse begin and the reverse end functions. So now the content, that is the pointer automatically will point to the last element because the reverse begin, right? It will point first, initially it will point to the last element, then it will point to the next element, that is the reverse order. It will move towards the beginning. So what is the result now? For 50, 40, 30, 20, then 10. Next, dereferencing the iterators. So the dereferencing operation allows the user to access or update the value of the element pointed by the iterator. For example, the vector, the variable collection of the values. So now it equal v dot begin mean the cursor it will start from the begin. Okay, now the first element, that is the dereferencing operator, then followed by we are using the variable. Now automatically it will show the first element. What is the first element here? 10. So now the new value is updated in this iterator. Here, right? So automatically the new value is updated now. What is the first element right now? 100. Initially it is the 10. Later we are adding the new value in this variable. So it is updated in the beginning. So now what is the first element right now? It is 100. Next one is the incrementing and decrementing iterators. Increment or decrement iterator by 1 using plus plus or minus minus operator. The increment operation move the iterator to the next element in the container. The decay operation move the iterator to the previous element. So increment means it will move to the next element in the container. Decrement operation move, the pointer is moved to the previous element. We will see one example. Vector v equal the collection of elements. Then it equal b dot begin. So now pointer is starting from the first element. So now plus plus I means what? Already it is the control is here. Plus plus means automatically the control is moved to one position. So what is the result now? So 20. Then minus minus means what? Already the content is in the 20. Minus minus means automatically it will move backward. So it is here. So what is the result here? 10. That will be written. So increment means the control is move towards this direction. Decrement means the control moves towards this direction. That is right to left. Next, adding and subtracting the integer to the iterator. The adding or subtracting the integer to the iterator, move it forward or backward, but only for random access iterator like vector and dq. We'll see one example. Vector v is collection of the values. So now we are going to start from the beginning, then it is stored in the it. So it plus 2 means what? Already it here, right? It means what? The variable, it is point to here. Plus 2 means what? It will control is move 1 and 2. So control is here. So what is the result right now? So now we are printing the current value, right? What is the result now? 30. What is the next operation? That is the variable minus 1. Already here, minus 1 means what? The control is move backward here, right? So it is here, pointer is pointing to this value. So what is the current value here? Now it is 20. Next is subtracting another iterator. Subtract one iterator from another to find the distance, that is the number of elements. So for example, vector v, it is collection of elements. So here we are creating two variables, it1, it2. it1 is start from beginning here. it2 is start from beginning plus 3. So here beginning plus 3 here. So what is the difference now? it2 minus it1. What is the difference here? 3. And next one is the comparing iterators. It will compare two iterator of the same container to see their relationship. There are different type of relationship, right? Equal, not equal, less than, greater than, less than or equal, or greater than or equal. So we can use anything here. We'll see one example. Vector v, it is collection of the element. So now here there are two variables. it1 start from beginning, it2 beginning plus 2. So here beginning plus 2 means here. So now we are going to verify if it1 is not equal to it2, right? So now automatically it will print like the iterator pointing to different element. Next one is we are going to compare it1 less than it2. So here it1 then it2 we are comparing, it is less than, right? So that condition is true, then it will print as it1 come before it2 in the vector. And next, some of the additional functions, for example, advance, next, and the previous. So the advance function, it will increment the iterator position till the specified number mentioned in this argument. And next one is the next. It will return the new iterator that the iterator would point to after the advance in position mentioned in this argument. Next one is the previous. It will return the new iterator that the iterator would pointer after decrement in the position mentioned in this argument. We'll see one. So the vector AR, it is collection of the element. So now vector, the PTR1 start from beginning and FTR1 start from end. That is beginning means here, end means here. So the PTR start from here, FTR start from here. So now next is the one of the function, then PTR means, right, this one, beginning comma 3. So beginning comma 3 means what? What is the result now? Beginning plus 3 means it will display the 4. And then previous is another inbuilt function. Now end, start from end, then 3. Then it will display 3. And next one is advanced functions. So here pointer is pointing. So here pointer is pointing beginning plus 3. Then automatically again the value is, it will be print 4. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss algorithm. So the algorithm has many inbuilt functions. We are going to discuss few important functions. For example, find, count, sort, search, merge, for each, and transform. We will discuss one by one with an example. So first we'll start with algorithm. So the algorithm perform operation on data which is stored in the container. This algorithm is available in the header file is algorithm. So what are the advantages of STL algorithm? Reduces coding effort, saves development time, efficient and optimized implementations. It will improve the code readability and reusable and reliable. We'll start with one by one. So first start with the find functions. It will return the iterator pointing to the first occurrence of the specified value in the given data ranges. For example, vector v is this collection of the data. So now here the iterator, it is creating the reference. So now here we are going to use the for loop. We are going to print the vector's value. For example, v is I. So now it will show the content of the vector. For example, 10, 20, 30, 40, then 30. So now we are going to search some element, right? So we can give any input. For example, I am giving 30 in the variable. So for example, yes here. So now find is the inbuilt function. We are giving the 3 parameter here. First one is begin. Then then till we are going to search n. Then mention the searching element. Already the searching element is 30. So now I mentioned the variable name here. So now it will return the position here. Then you are going to verify whether it is end or not. It is not end, right? So now automatically it will print the message like element, the search element is 30, right? Element 30 found at the position. So what is the position? What is the position of the 30 here? 2, right? 0, 1 and 2. So it will display like that. The next function count. It will find the number of occurrence of the element in the given range. For example, the vector is collection of some of the element. So we are going to count, start from beginning, then till end. What is the reference value here? 2. So number of time the 2 is occurs. See, 1, 2 and 3. So 3 times it is occurs, right? So the result is finally the result is 3 here. And next one is the sort functions. Sort the element in the container or array. By default, it is the ascending order. For example, it is the array that is the collection of element. So here we are finding the that is n value equal size of the array divided by size of the that is air of 0. So then it will find the n value. So what is the sort here? So sort is the inbuilt function. First argument is the array variable, then array plus n. So now automatically it will sort in the ascending order. With the help of the for loop, we can display the content of the array here. See, it is showing in the ascending order. And next one is the, if you want to show the descending order, one small difference. So here additionally we are adding third parameter. For example, ARR. Then similarly AR plus 1, n, comma, the greater than int, this function. If you are calling this function, it will show in the descending order. And next one is the search functions. It performs searches for a given sequence in the given ranges. For example, vector v1, it has some other value. Vector v2, it has some other value. So next, we are creating the one reference, the iterator. So now we are going to start from begin. That is search is an inbuilt function. The first parameter start from begin. We are going to search n in the first vector. Then second vector begin and n. Now we are going to verify the second vector content is present in the first vector content. If it is present, find the positions. So now what is the position 3, 4, 5? It is start from where? The first vector 0, 1 and 2. So here it is starting, right? So now it will display And next algorithm, that is one of the function merge. It will merge two sorted container into single sorted container. So for example, vector. So here vector, the variable is got some other value. Vector 2 has some other value. Then we are creating the third vectors. So 2 vector and here is the third vector, empty vector. So now first vector is we are sorting. Similarly, the second vector also we are sorting in the proper order. Then after sorting, so we are calling the merge functions. So here first that is the ARR1 dot begin, then ARR to end. Similarly, the second vector, right? The second vector dot begin, second vector dot end. After merging first vector and second vector, the result stored in where? That is the ARR3 dot begin. So here we are storing. So now we are going to display ARR3 dot size. We are going to search one by one, then we are going to display. So now the content of first vector merge with the content of second vector, the result stored in the third vector. Now it is to display like that. And next one is a for each. It will apply a specified function to every element the given range. For example, so we are writing some other function. So here a parameter, then we are going to display the content of the x value here. So now here the array is collection of the element. We are calling the for each functions. So here they are giving the 3 parameter. First one is the array name. So array plus 5 mean, so that is the ending name, right? Starting and the ending we need. That is the ending position. Then we are mention the function name. Here is print. So when the statement is executed, the control is automatically move to here, then it will print the x value. So what are the content inside the array that will be print, right? 10, 20, 30, 40 and 50. And next one is the transform. It will apply the operation to each element of the container and store the result in another container or in the same container itself. So for example, here is a double and here is the array name. It is collection of some values. And next one is the that is the empty array. Double, there's empty 5 is on empty array. Then is the one of the prototype function prototype declaration. So here we are calling the transform. So first parameter, the first array name, comma, we are going to search till end, right? That is inches plus 5. I mean, it will search till end, then mention the function name. So here the same function is define the outside here. So see, so where we are getting some of the input is multiplied with 2.54. It means that is the centimeter. Here the inches is converted into centimeter. This is a formula. So we get the input from array, okay, and apply 2.54 for each element, and then it will convert into centimeter. Then return means automatically control is come to here, then it will display the values. So what is the concept here? We are going to apply some of the formula or some of the modification each element in the array. So then it will be reflect, then we can display. So now 3.5 into 2.54, then it will reflect. Then 6.2 into 2.54, then it will reflect like that. So the value it is affected each element in this array, then it will display here. Thank you.